Okay, just making a quick update on my research and just wanted to thank people for checking out my research online in lieu of my recent talks that I gave for the podcast with Mark Palmer Steves Jr. And so I was reviewing my research again, and this whole idea of how is space-time created? How is the 0 point of space-time created from the time frequency resonance that is non-local, aka non-commutative? And so Alon Khan, in his talk, he says that basically you have a finite dimension for the point of space, but what he's attempting to do is to not require any kind of coordinate system of units. And so when we look at the speed of light, as a constant, it's defined by Einstein as just pure magnitude. But Alon Khan is saying that if you're using that as a constant, then when you look at the frequency of the light, then the wavelength is actually the inverse frequency. And so you have this, before a 0 point of space-time exists, you have this negative frequency and time-reversed virtual photon with the photon, and that this process then is modeled on a Dirac operator that is like a differential on a spinner, which is also called a two-sphere or a block sphere. So you need this internal flip of the 720 degrees of the sphere to then, that's non-commutative, to then create this 0 point in space-time. And so then the 0 point in space-time is actually from a chord of two frequencies, but it turns out that because it's non-commutative, it's actually three frequencies. And so this is called the fermion propagator that's inverse to the Dirac operator. And the reason it's non-commutative is because it has 1/2 spin as matter. So it's either the proton or the electron with 1/2 spin. So this is another way of explaining how all matter is actually made of light. And there's no center of mass to measure it. This is also explained in the Light is Heavy article by Gerard de Hooft and Martin van der Mark. In that case, they're using a box, like a box. If you contain light in a box and you measured its pressure, it would have gravitational mass, the light. But in this case, you're having a positive pressure that is anti-gravitational, as what they call in the weak measurement experiments negamass, or negative mass that's gravitationally propulsive. So it's anti-gravity. And so Alon Khan says, well, it has a geometric dimension less than any positive number, and it's the spectrum the continuum is more dense than the rational number continuum, but yet it has positive volume. And so what does that the positive volume means that it's anti-gravitational, but it's also information as force. So it's negative entropy, and it exists before a linear spacetime. So he calls it like a infinite dimension of infinity, or infinity of infinite dimensions, that then creates the passing of time as space-time. So how is this possible? Well, he says, music theory is the simplest way to explain it. And so when we look at music theory, if we have the spectrum as the point is the symmetric pitch. So you have like what they call octave equivalence. So it has the same geometric point. So if the 1 is C, the 2 is C as the octave. But then the next natural resonance as the overtone is 3, but it's non-commutative. So if you have you have this multiplying as a exponential growth of the frequency as a 3/2. So when you're trying to create the music scale, you try to line up the octave with the perfect fifths, and it doesn't quite line up. And so in normal music theory, they just sort of average it out and assume that you have a symmetric logarithms. But Alon Khan is pointing out that the discrete numbers are actually they're non-commutative as exponentials. So you have like, if you have 3/2 squared, which would be the perfect fifth, that gives you 9/4 which would be like a major ninth interval past the octave. But then you want to build up the scale of the same 12 notes in the same octave. So then you divide it by half. So you're like multiplying and averaging. And so you get 9/8 as the major second music interval. And then when you cube 9/8, you get the approximation of the square root of 2, which is the original power axiom set for irrational magnitude in science. But in terms of the origin of the irrational magnitude, it actually is derived from this non-commutative process. So if you have 3/2 squared as 9/4, well, when you invert it, it's actually inverting as an exponential, because since you're multiplying it, so it's actually 2 to the 3/2. So when you have 2 to the 3/2, then you're getting this cube root of 2. And so originally with Archytas, he was relying on this equation from Babylonian mathematics, where you have the arithmetic mean times the harmonic mean equals the geometric mean squared. So again, you'd have 3/2 times 4/3 equals 2, and that would be the geometric mean squared, which would give you the tritone as the square root of 2, if you have it as the geometric mean of the scale, which I just pointed out is the 9/8 cubed approximated. So there's different ways of deriving it. And so then what he did was say, well, if you have 3/2 as the geometric mean squared, then you have 5/4 as the harmonic, or as the arithmetic mean, and 6/5 as the harmonic mean. So that gives you 30/20, which is the geometric mean squared. So then you'd have the square root of 3/2. But the problem when you're doing that is you're assuming that 3/2 is this geometric mean. But Alon Khan has pointed out that 3/2 is not a geometric mean. It is a non-commutative ratio of the 1. So when you have the 1 as the root tonic or home tone, then the 3/2 is C to G as a perfect fifth, and then the 2/3, which is also a perfect fifth, is C to F as an undertone. And then, so in order to try to make that into the same octave, you have to use a different root tonic using a double octave, and this is what Philaeus did. So he flipped his musical instrument around the lyre. So then he used 0 to 8 as a root tonic. So then he was able to create the first logarithmic equation, because then he had 6/8 as 3/4 wavelength for 4/3 frequency, and then plus 8/12 as the 2/3 wavelength for 3/2 frequency. So then you have a logarithmic equation of the geometric mean of 8/6 plus 12/8 equals 2. So then you've created 5/4 plus 4/5 equals the octave. That's the first logarithmic equation. The problem again is that you've covered up the fact that you've changed the root tonic of the one based on listening. And so Philaeus just said, well, it's a ratio of ratios, and so it doesn't matter that you've changed the root tonic as listening, because you're trying to create these geometric magnitudes that are visually symmetrical and commutative. And so what Alain Kahn is saying is that since you have a different value of 0, like in the case of Philaeus, you have 0 to 8, and then you have 0 to 12 for the value of 1 and you can think of 1 as the home tone, or the 0 point of space-time. And so Alain Kahn is pointing out you have this inherent different coordinate of 0 point of space-time based on the order of the measurement of the frequency of the light. And so when you change the order of the measurement of the frequency of the light, and this is what Heisenberg originally discovered about the Ritz-Rydberg combination principle in spectroscopy, is that it's inherently non-commutative. And that's what then became the Heisenberg uncertainty principle of position and momentum. And then de Broglie realized that momentum is directly proportional to frequency, and so the position would be the wavelength as the time. But again, Alain Kahn is pointing out that when you have the time is actually just the inverse frequency instead of wavelength. And so then you have this inherent non-local force that's actually anti-gravitational. And it's also harmonic. It's like inherently harmonizing reality from the future. And then there was another math professor whom I corresponded with a little bit, I think, if I remember correctly. And let's see if I can remember his name. Let's see. But he actually argued that, well, if you look at a singularity of a black hole, it's actually being stabilized by the non-commutative quantum foundation of reality. So you have this anti-gravitational pressure that's then balancing out the collapse of the black hole. So then essentially every black hole is a quantum wormhole. And this is something that my own quantum physics professor, Herbert J. Bernstein, pointed out that Einstein actually was considering this option when he was creating the Einstein-Rosen, the EPR paradox of quantum physics, which is Podolsky and Rosen. But then around the same time, he worked with Rosen to then create this wormhole concept of black holes. So even then, Einstein had realized there's probably a connection to, on the quantum level. And so, as Alain Kahn points out, this this discrete time frequency is more dense than the real number continuum, and also it's an infinity of infinite dimensions. That's negative entropy before linear time exists. So he calls it primitive time, before the passing of time as a increase of entropy in space time. And so then again, you can, if you think of this in terms of non-commutativity, I mean, it makes sense because you have this constant, the irrational numbers are actually derived from, as he pointed out, it's like if you have 2 to the 19th and then 3 to the 12th for the Pythagorean comma, then when you try to put it back into the same octave, you have 3 to the 1/19th and 2 to the 1/12th. And so that's why, again, you're having this non-commutative overlap of the time and frequency because the exponentials are non-commutatives. So he also calls this a double quotient. Again, the example being 2 to the 3 halves versus 3 halves to the squared. So by hiding that discrete non-commutative source of time and frequency that's non-local, then Archytas extended the Pythagorean tetrad to 5/4 as an approximation of the cube root of 2, which originally was 2 to the 3 halves. And so as 5/4, then you have this extension of the Pythagorean tetrad. So when they had a rediscovery of Platonic philosophy, then they could, in the Renaissance, then they could do three-dimensional perspective as the definition of space-time, being so-called realistic, compared to like when you look at like the earlier artwork and there's like auras around the saints or Jesus or whatever, and that's actually more realistic truth of reality. Instead, you had this like three-dimensional perspective drawing that's assuming this geometric commutative or symmetric ratios of ratio, and which would be, so you have 5/4 approximating the cube root of 2, but when you use 5/4, this is what Simon Stevin used in the late 1500s to then create the first equal temper tuning. So then you have the 12th root of 2 defining the whole scale, which is what the modern tuning uses. And you also are assuming that frequency is defined by Hertz, which already assumes this geometric definition of space-time. So there's a very simple secret to the mathematics that Alain Kahn discovered, and I discovered it, through my music theory class when I was like 15. And anyway, I just want to thank people for checking out my research again, because that inspires me to revisit my research. And yeah, we'll just leave it at that. Actually, I'm looking at this book here. This is the quantum psychology book that Eddie Ocean's. I cite this in my more recent papers, but let's just quote what he says here, that I'll just see if you can read it. It's going to be like reversed. I have it circled. Does it focus? It's not going to focus. Anyway, so it says, I had been thinking about the suggestion to apply the mathematics of group theory to linguistic interaction and then blah, 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 because of their misdefinition of mathematical groups as being, quote, commutative, order independent, since all quantum interactions take place through the property of being not being commutative. I had come to the Research Institute from New York to discuss this issue. Blah, blah, blah. So this proves that the non-commutativity was the main inspiration for Eddie Oceans to then create what he called quantum psychology, and to explain that the truth of Neigong, or internal martial arts, is actually from the non-commutativity, with this hand movement as the Dirac dance from my own quantum physics professor. And then he has this great phrase that I quote in this article I was just reading that I wrote. But he says that what does he call it? The spinorial virtual information in the brain. So what he wanted to do was to have people doing the Tai Chi exercises, like the silk reeling exercise, which is the Dirac dance, that I showed before, where you keep your hand like that and then you twist it around and flip it around, and then he wanted to have people be in a fMRI so that he could show that this virtual information, spinorial virtual information, was actually increasing the conductance in the brain as like a Josephson junction effect that's transferring the non-commutative frequency into an increase in amplitude. And what's really fascinating about this is I tried to talk to Brian Josephson about this directly, and he himself, he knows it's a space-time asymmetry. He said in his Nobel laureate lecture that his Josephson effect of having two superconductors that are thinly separated by an insulator, and that is the definition of volt. If you look up the National Institute Standards Technology definition of volt, they rely on the Josephson effect to explain the origin of volt. And what they're saying here, what he says in his lecture, that it's due to a space-time symmetry breaking. But what the quantum physicists are emphasizing is that symmetry breaking is inherent to the non-commutativity of the virtual photons. And so then Basil J. Hiley points out that with Richard Feynman, he assumed what he called renormalization, was assuming that you have to change the mass. So if you think of the mass as the matter that exists in the 0 point of space-time, well, the photon does have gravitational mass due to this quantum pressure of momentum. But since there's no center of mass, you have this constant fluctuation, and it appears to be a change of the mass. But it's actually this anti-gravitational force that then we experience as a change of space-time, as mass, in our 4D reality. But it actually originates from this fifth-dimensional non-local force. And so that's what Basil J. Hiley, that's his big point, is that both Richard Feynman and Dirac were wrong, because they both ignored this quantum non-commutativity that's inherent to the Schrodinger wave function that Schrodinger got from Louis de Broglie, and that it's due to the imaginary number as time. So you have this, in quantum physics, they normally just consider it like a complex number in 2 dimensions. But if you say just complex number, you're already assuming it's a symmetric mathematics. So it's not actually complex, it's actually this non-commutative time shift, as Eddie Ocean's collaborator Lou Kaufman explains, a math professor, that the algebra is inherently a time shift, because whenever you make an external measurement, you have to actually take time to make the measurement. So when you have to inherently take time to make any kind of measurement, you end up getting this non-commutative time shift to the one. Like if you had, 1 or -1 as the phase of the frequency. And so it's that phase of the frequency being non-commutative that then creates the amplitude resonance. So you can think of it as like a subharmonic of the frequency then creates a significant increase in amplitude. And that's actually a quote from Brian Goodwin, who was a quantum biologist. So the scientists have been sort of like on the verge of figuring out this non-commutative concept and how it's the origin of energy in the universe, and also information, and how it's connected to the imaginary number as the phase that then creates this new definition of time being inherently asymmetric, because it's an eternal motion from the future guiding matter. And anyway, so I'll just leave it at that. Let's see what we got here. 26 minutes. And yeah, that's pretty much all I can ramble on about. But my main point was like how to connect it back to relativity and how space-time is defined in relativity, because obviously science relies on relativity for GPS or whatever. And but when you start to understand that space-time is inherently curved due to this non-commutativity, then you have this this inherent curvature is actually a new type of force, and then in quantum biology you can resonate it and self-amplify it into the macro scale, because the non-commutativity no longer has this quantum wave function collapse problem. And essentially the limit of this is what Basil Jahali gets into the details about, because he's talking about h bar squared, Planck's constant squared, in terms of you're basically like creating the point from the non-commutative time and frequency as the energy of the light. And I don't know all the details about that, but the problem is that Dirac and Feynman both tried to dismiss this h bar squared as like a non-consequential extension of the energy. So, but in fact, again, if you can maintain it in quantum biology if you're relying on listening as music, because you don't have to have any kind of external measurement when you're relying on listening as music, as meditation. And of course, that's what my research focuses on. All right, we are coming into the half hour. So, yeah, I think that's everything I wanted to say.